We are talking about absolute value equations and inequalities, and we want to evaluate expressions involving absolute value, solve absolute value equations, and solve absolute value inequalities. So the steps are pretty similar to both. So steps to solve the absolute value inequalities. Get the absolute value by itself. That's the same step. Steps to the absolute value equal to the positive and negative version of the number. That's the same. We had to add step 3. Change the direction of the inequality sign for the negative version. And then step 4 is the same as step number 3. Use GEMDES to solve for the variables. In order to get the absolute value by itself, we will also have to make sure that we use GEMDES. And remember, we start and we work our way back. So first step, in this case, it's done already. Step number 1 is done. Get the absolute value by itself. So there's no operations outside of the absolute value. Set the absolute value equal to the positive and negative version of itself. So I'm going to do the positive version, which is x and 10. And then we're going to use the negative version, which we leave the absolute value alone, but we change the answer there. So that's going to be step number 2. Step number 2, that's positive and negative. And then step number 3, we have to change the direction. So we change the direction of the inequality sign. So whatever direction was facing before, we leave it. And when we add the negative, that one we have to change the direction, because really it's like multiplying by negative. And anytime we multiply by negative, we have to change the direction of the inequality. And then from there, we just keep it the same as we had before. There's nothing to solve. And then we have to remember that this is less than. So we have to remember that this one is less than. So remember, this one has to overlap because it's less than. So I'll show my work on the number line. So here we have x is less than or equal to 10. So less than or equal to 10, I'm going to put 10 right here on the number line. Less than or equal means closed dot, and the variable's on the left, so I'm going to shade the same direction that it was before. Then here we have x is greater than or equal to negative 10. So I'm going to put negative 10 right here. Less than or greater than or equal to, so that's still going to be a closed dot, and I'm going to shade to the right. Now, and means intersection, so it has to be in both sets. So my final answer here will be negative 10 with a closed dot and positive 10 with a closed dot, and then I'm shading in between. So that's the final solution graphed. Then we have to remember set builder. So set builder, it starts from negative 10 and goes to positive 10. So negative 10 to positive 10. And then the variable goes in the middle with the correct signs pointing. So between the blue 10, x, the arrow points to the x, so that's pointing to the x. And between the negative 10 or the red 10 and the x, the arrow points to the negative 10. So I need to make sure the arrow remains pointing to the negative 10. And for interval notation, we start with the lowest value, which in this case is negative 10. And then we go to the highest value, which is positive 10. And we remember that if it's included, that's a bracket. So we keep the bracket on there.